3, continuing with the gravity theme, this time knowing that that's the radius of Earth and knowing that that's the mass of Earth, what is the gravitational field constant for Earth? And the answer is, you know it. It's 9.8, okay? But we're going to calculate, so show you how to calculate it, or remind you how to calculate it. So when we say gravitational field constant, that's G that we're looking for. And again, it's how much force would 1 kilogram of mass experience on Earth. And that number would be different anywhere else in the universe. But on the surface of Earth, it's going to be 9.8. And let's just go ahead and see why. First of all, the way you do that, assume you have a mass of m. M could be any number you want it to be. And you could represent any object. So Charlie's here beside me, so I'll pretend m is Charlie, his mass. And he's sitting on the surface of Earth. And I want to find, I'm going to use the force of gravity on Charlie. So between Charlie and the Earth, using this formula. And then that's the mg one, the force exerted on Charlie by the Earth. That's what those two represent. Anyways, I showed you this last year. The idea is that you make those two equal to each other. M is the mass of Charlie, shows up on each side, so it cancels. So you can find G using this equation, and it's true anywhere. And doesn't, I said Charlie, but it could have been a coffee cup, it could have been a bag of potato chips, it could be anything, because it cancels. We don't really care about M. Anyways, the point is, here we are. Here's our gravitational field constant equation. So you sub in G being the 6.67 times 10 to the negative 11, the mass of the Earth, big M is the mass of the Earth, and R is the radius of the Earth. And you should end up with 9.8. And I know that's a good answer, so I'll definitely check mark that baby. Good work, Miss Stone. And just the units. Units are something that I think if you're thinking of higher, like taking physics in university or something, it's time to be thinking about where some of these things come from or why they are what they are, and really understanding how to use the units. So I say that the units are newtons per kilogram. I also say they're meters per second squared. But if we're looking at the newtons per kilogram part, like let's just look at this equation and pretend there's no numbers, everything's 1. But let's just look at where the units come from. So this is the units of big G, right? That's the unit of the mass of the Earth in this case. And that's the units meters squared of the radius squared. And so if you look at that kilogram cancels out that square, right? That meter squared cancels that meter squared. And then you end up with just newtons on the top and kilograms on the bottom. Okay? I wouldn't put that on a test for you, but like I say, if you're thinking higher level physics, you should be thinking about how those things make sense. Anyway, another easy example done.